Hello everyone, my name is Abhishek Jain, and through this video, we are actually continuing to build our own automation framework for a functional as well as for the non-functional testing, right? In the previous part, we have just covered how we can automate the performance testing by using the Locust library of Python, which actually provides us the flexibility to write our test in Python language, which is very easy to understand. And this is what we have written in the previous video. If you haven't watched that video, if you are really interested, you can watch that video, or you can just read through the Locust documents or go through the Locust tutorial. It's very easy to do, right? In the previous part, when we run the performance test, we got into the two exceptions. So basically, we were able to break our application, and that is what the primary role of our QA or the test, right? So we got one exception related to the Postgres where we were having so many SQL claims. It means that dev has to fix it. When I say dev, it means that I have to fix it because I have written on this simple web server. Same thing we got in another fast API exception. Again, that exception has a link where you can just go to the documentation of fast API and you can fix that part as well, right? So in today's video, what we're going to do is now, in the previous part, we have just simply utilized the default, uses of all the number of CPUs and cores. But Locust is very smartly designed, where if you have multiple cores and multiple CPUs on your machine, you can use them very smartly with some of the options, which is basically actually helping us to utilize all the CPUs and try to mimic the environment where we are sending a load to our application from a different machines. And same concept we can use with when we want to utilize the machines which are running on clouds in a different infrastructure. We can use them provided we have a proper connectivity set. And Locust use a master and the worker concept, where the master process actually is responsible for making sure that the expected number of worker users are there or not, and then it distribute the load to those workers. And after once those workers are able to run those load, then it collects the log. So now, without further delaying, let's get into the demo part. And if you are really interested to see the previous part and the other parts where we have automated the functional test cases, you can see the link for all those parts one by one on your right top of your screen, right? So this is the simple test which we have written, which actually run against these four endpoints. We are not testing metrics for now: post, get, put, and delete. So basically, we are just covering all the majorly used REST API endpoint stuff, right? And let's quickly run this. What I'm doing right now, I'm just running with the simple way, the way it just run, right? So now if I just go to the Locust, which actually runs on 8089, if I just start this, it's going to start with soon. Here we have a 1, right? Now there is no issues with this. And if we just come down here, there is nothing but what we can do. Here we can see open resource monitor. And we can click on where that more details, performance, open resource monitor. So we can see the CPU uses and the memory and everything here. Good. Now, if I just go back to Locust here, it looks good. Let me just stop this. And now we want to distribute the load and we want to utilize all the number of CPUs we have on our machine, right? So what I'm going to do here is, all you need to do is to utilize this flag, which is nothing but master. And then you have to say how many workers you are expecting to be there. So I'm saying 2 workers. So what does it mean? Master will wait for 2 workers to come on that, right? So let me run this. Now come back to the Locust and see what is happening here. So let's start that. Let's see. Now you can see we have this additional worker, but we don't have anything, right? And another, again, we have in a banner also, we have this work, right? So what we need to do is we have to go to the performance and again, and let me just bring this command. And here I have to say worker, and I have to say master host. And just here. So now we have started one worker. Let's see what happens. Okay, so we can see ready, which is one worker here. Okay, and let's see on a previous terminal where our master is running. So now we can see this message where it says one worker is connected, right? Let's run same, but this time we are using a worker as an option along with the locust command and the master host. This is also running without any issue. Let's come back here, refresh it. And oh, here you can see we have now two workers, right? And if we just click on this workers tab, we can see two workers are in a running list. And there is only one user. So let me just stop that for now. And if I just go back to my master, let's see, yes, it says two workers are connected. So what does it mean? It means that, you know, the moment you have the expected number of workers, then only master is going to start start distributing the load among the workers, right? So let's see what happens, right? So if I just come back here, and if I say I need 4 users and I want to ramp up with 2 and once option, I just wanted to run this for, let's say, 10 seconds and let's see what happens. Okay, so right now, if you see, we don't have any users, but now we have 4 users, we have 2 workers. If I click on here, now we can see the first worker where we have 2 users and another worker we have 2 users, right? And if I just go back to the statistics, let's see, this looks good. If I just come down here where my server is running, we can see the requests are being fed only for 10 seconds. Now, that's the way you can have more, you can utilize, you know, your CPUs more effectively, right? In this, okay. So here we can start seeing few things. How many CPUs we have? We have 16 CPUs here on my machine, right? And if I just come down here, it's 28%. Another thing which we want to see. That's good. Okay, so now we can see 20 CPU, and if I just come down here, processes, everything looks good. But here we can see a lot of PyCharm and Python related, you know, processes are. Let's run master. Let me just kill this, and let me run this master with 8 nodes, right? Rather than 8, let's start with 6 first. Okay, and here the first one, the second, and just the third one. Okay, next is the fourth one. See, we have 5 workers connected. I'm just supposed to run another one, but before that, let's try to see what do we have here. Statistic. We have 5 workers, but when we have 1 user only, none of the you know, one, right? So let me add the 1 more workers. Okay, so let me just get through. Okay, come back here on the master mode. 6 workers are connected. This looks good. Let's keep sending. Let's stop this. We have 1, 2, 3, 4, 5, 6. We have 6 workers. If I say 12 number of users, start with 2. It's run for quite a long time. I haven't given any name. It means that it's going to run forever, right? So let's see what's happening. All the 6 working users are connected. That's good. Let's see on the CPU uses, you know, We can see the CPU usage is actually getting increased. We can see initial CPU, CPU2, CPU4, some CPU. Seems like, every CPUs are now getting involved because now we are actually utilizing by distributing our load to the respective CPU with the help of these master and the workers concept which Locust actually provides. This actually works more effectively on when we have different physical servers or the cloud infrastructure where we can have our own machines, where one machine can act as the master and the rest of the machine can work as a worker, because that's actually going to mimic the actual real situation, right? So if we just come back here, this looks good. So we have 12 users now, 5 workers. I think this is the problem. We have to, refresh this, and otherwise it should have updated. So this is something which Locust has to take care of. We should not worry about that. We are getting 4.9 RPS. Let's see on my database. Everything looks good. Okay. So now do try to just break this application with having more number of focus. So let's say 10. So we have 1, 2, 3, 4. We can automate all these things, but not in this video. But we just wanted to see how we can leverage this distributed mode to utilize all the CPUs which we have. Okay. So let's see how many workers we got. We got 8. One. Okay, so we have 10. Cool. So now coming back to the Locust and refresh it. Okay, now we have 10 workers. So what I'm going to do, I'm going to say 100 user, ramp up rate for the users 10. We'll start. Let's come back here in workers. So we have 10 users, refresh 6. Then means we have now we have 100 users. We can come here, you can see in the charts on this progressing. We can see the response time, request per second, everything. Utilize all these steps. You can understand the documentation, understand everything here. Everything looks good. In current ratio, you can see how the ratios are, for every task which we have in a test. Download data, you can just download all the exception, failure, request, and report the charts, information, and everything. This is the logs for workers and everything. This is the worker detail, right? How many memory and the CPU uses we have, right? That's one thing. The other thing is we can come down here. We can see how the CPU, utilization is happening. See, most of the CPUs are being utilized. Right? So that is how optimally you can use one machine by having this master and working concept, right? To make good use of your high-end machines, right? That's one thing. Let's see if we are not getting into any issue. Good. Cool. So far, oh, cool. Now we are able to get into the same issue which we were getting into yesterday. Too many SQL, so this needs to be fixed. Okay, so let me just stop this for a moment and let's do a very funny thing with this. And you can see we have 25 requests per second. That's really awesome. Let's make it 1,000. Let's make it 100. Probably it's very easy to make your application, right? And it's just few click away for any person to break the application very easily. Statistics, we have 36 or 21.1 requests per second. That's really awesome. Charts, we can see and analyze the chart, the request per second. Also, we can just see the response time, number of users, 1,000 users, number of actually responding to every request. Coming back here, exception. Do we have any exception? Statistics looks good. We have some followers, right? Seems like just one application. Cool. Seems like we are able to get into the another issue below. The way to break the application once we have 1,000 number of users. Let's see if we have another exception. So basically by having 1,000 users, now we are able to get into the situation which we can quickly search when such thing happens. We can use Windows and ChatGPT, right? So we can check here. Also, we can quickly check for Gemini. Okay, so I can quickly select the question which I want to use. Okay, so we have first API server where we are doing ValueError 2.5. Okay. More file descriptor, file socket than the limit set by the operating system. Here, it seems like the first API was made, and we are doing the performance testing with the Locust. Check the current number of descriptor using your and command, right? To make the channel permanent, you have to change into system dialog usage, require application permissions, the target goes properly after. So it seems like the we have to do a little bit of setting in our application, and as well as we have to do some analysis or profiling on our application to see if we have any resource which we are not releasing, or probably what we can somewhere thing is something which staff can do. They can do the profiling and they can figure this out in this situation is happening and why this is happening. Probably this is not something which we should be doing, right? But see how easy it is to just break the application with Locust by having whatever number of users we have. And we understood how we can have, how we can utilize all the CPUs which we have in our machine, because right now we are living in a day where number of CPUs is very high and we should be utilizing all of them, right? So that's the best way of doing it. So cool, this looks good. And another way of just breaking the application, and we just got to know how we can distribute the load by utilizing all the CPUs and the cores we have on our machine, right? So thanks for watching this. And if you have any suggestion or feedback on this, feel free to just put that into the comment section. And if you want to see my previous, videos, I will just provide the link in the description. You can just watch them if you are really interested. But I would highly recommend go to the Locust documentation, try to understand by yourself what all other powerful feature Locust provides, and try to utilize them to just break your application as much as you can, so that customer in real time won't find those simple issues which Locust can help us to find out very, very easy, right? So keep learning and stay healthy. And thanks for watching this once again.